Well, folks, now we're going to have a look at 2017, question 4, part A. So this is a nice little straightforward pulley question, but it's asked in a slightly unusual way. Because instead of having just masses at the end of it, we're told that we have little scale pans, so just like a little pan, and weight put on it. Well, let's draw a quick diagram of what this looks like with the bits and pieces put on it. So we're going to assume everything is like a single weight. Well, A is mass M, and we're going to put a mass of 3m onto it, so it's mass 4m. And B is an empty pan of mass m. So now, once we've got past that first little bit, we're back to our normal kind of question we're more used to. So if we draw a quick bit of force diagrams on this one, we have the tension acting upwards on each one, the string. Okay, and our weight going downwards. So weight in this one is 4mg, and this one is mg. Alright, now there's a few ways you can do this. I like to kind of figure out a little bit of common sense. Which way is it going to move? So the acceleration is going to be in this direction. I write it down. Now this one's very straightforward, but on the more complex questions you might have an A and a B if there's multiple pulleys. So let's have a look at this in terms of F equals ma. Well, look at each one in question. This is going to move down, so we have 4mg minus T equals 4ma. That's fine. And the other one is going to go up this way. So we'll say T minus mg equals ma. And the nice thing about doing it this way is that our T's are going to cancel out, just like that. So we can take those as two simultaneous equations, bring them together, and we end up with 3mg equals 5ma. Quick little cancellation of our m's. And bring that across, we're going to have the acceleration is 3 over 5g. Okay, so that's the first bit of it. But when we look at part 1, we're looking for the tension of the string. So this is kind of like useful piece of information number 1, but we're not quite there yet. If we call these equations 1 and 2, let's just take the simpler one, which is going to be 2. So using 2, we are going to sub it in. We're going to sub in A into this equation. So T, just lay it out nice and easily first, equals ma plus mg. Putting in A, that equals 3 over 5g by m, of course, plus mg. So our tension, 3 over 5 plus 1 is 8 over 5 mg. And there we are. Now we have our tension. Just nice to the camera. Okay, so that's part 1 sorted out. What about part 2? Little line here. Well, part 2, how far has B risen when it reaches a speed of 0.4? So again, they're making you think a little bit in this one. Where are we going with this whole thing? Well, let's see what we have. We know its initial speed, 0. Okay, U equals 0. We know 0.4 is going to be the final speed, 0.4. We want to find S. What else do we know? Well, we know the acceleration. Acceleration is 3 over 5g. Okay, now we go back to our V equals VUAST equations, our linear motion equations, and see which one of those has all of these guys. And it is, of course, V squared equals U squared plus 2AS. So, using that equation, we have 0.4 squared equals 0 squared plus 2, 3 over 5g by s. Okay, and it's no harm to write these guys out just like this up along here, because the temptation, the silly mistake you're tempted to make is to actually think, 8 over 5 mg, that's the value I found, and to pop that in for the acceleration. Okay, a little bit of algebra, 0.16 equals 6 over 5 gs. So we want to find s, so s equals 0.16 by 5 all over 6g. It's time to turn to our calculator for this one, and that is going to be 1.6 by 5 divided by 6 by 9.8, and that is 0.0136 meters. Okay, not particularly far, but again, you can imagine 0.4 meters per second isn't very fast, so we wouldn't expect it to have gone very far at this stage. Okay, That's part 2 done. Now, part 3. This is a bit of an unusual one, and we wouldn't always see a reaction force in this question. So this is where we do get a little bit of crossover between questions. The reaction force on the 3m mass in terms of m. Okay, well, let's just draw, like always, draw a little picture. There's a little scale, okay, and that's our 3m mass on it. It's got like little stringy bits, you can imagine on the scale, and that has the force T pulling it upwards. So the reaction force we're looking at here is the reaction coming up off the pan. That's ore there. Of course, we'll have a 3mg down. So we're just considering 3m mass. Okay, that's all we're going to do here. We're not going to worry about all the other bits and pieces. So the 3m mass itself, so weight is putting it down, there's a reaction force slowing it down, and its acceleration, well, the whole system is accelerating 3/5g. And if you think about this one, if there wasn't a reaction force, what would acceleration be? It'd be g. Alright, so something is slowing it down, which makes sense why acceleration is less than g. Okay, and I think in this case we're going to pop up here. So using F equals ma, well, 3mg minus 4 equals 3m, and we know the acceleration at this stage, 3/5g. Okay, so we'll do a little bit of tidying here, and bring this guy over here and that guy over there, so 3mg minus 9/5mg equals ore. So, because it's late in the day, we're going to use a little calculator for this one. So 3 minus 9/5, 1/5, so 6/5. So ore equals 6/5 mg. And there we have it. Okay, g is of course constant, so the only unknown in this is m. So we've answered this in terms of m.